Hello students, I am Praveen Kumar from ABS Engineering College, Ghaziabad. In this video, we are going to discuss the frequently asked questions from this unit electrical machines. So first of all, we have some previous year's questions. So this is the question paper of even semester uh, in session 23-24. So first question is explain the working principle of three-phase synchronous motor and also explain any one starting method of synchronous motor. So for this question, you can refer the video of synchronous motor in which it is clearly explained that this motor operates on the phenomena of magnetic locking and this motor can be started with the help of say pony motor or with the help of damper windings or with the help of DC machine. So you can refer that video and you can clearly answer this question. Then the next question is draw and explain slip torque characteristics of three-phase induction motor indicating starting torque, maximum torque and operating region. So a separate video in of slip torque characteristics of three-phase induction motor is available. You can refer it and from that video you can clearly find out the stable operating region and unstable operating region of the three-phase induction. Next is a numerical problem based on slip, which states that a three-phase 440 volt 50 hertz induction motor has a slip of 5%. What will be the frequency of rotor current? As we all know, frequency of rotor current Fr is equal to S times supply frequency. So this Fr is nothing but the supply frequency is 50 hertz, so it is simply 5% of that 50 hertz. Simply S can be written as 0.05 into 50. So going to the next paper, in odd semester 23-24, the various questions asked from this unit are, first is the what is function of slip ring in three-phase induction motors. So while discussing the rotor construction, we have already discussed that in induction motor there are two types of rotor. One is squirrel cage and other one is phase wound rotor, in which slip rings are there, and the provision of slip rings helps us in adding the external resistance in the rotor circuit for improving the starting. The next question is describe the working principle and torque slip characteristics of three-phase induction motor. So for this question, you can refer both the videos of three-phase induction motor. In one video, the operating principle is discussed, and another video, the detailed discussion is there on slip torque characteristics. So the slip torque characteristics and operating principle, two are most important topics, and they are very frequently asked in examination. Next is derive the expression of torque for a DC motor. So for this, you can refer the video in which we have derived the expression of armature torque. And then there is a numerical which is based on the line diagram. It states that a 6-pole lap wound DC shunt motor has 500 conductors in the armature. The resistance of the armature path is 0.05 ohm. The resistance of the shunt field is 25 ohm. Find the speed of motor when it takes 120 ampere from DC mains of 100 volt and flux per pole is 0.02 Weber. So for this numerical, first let us draw line diagram of a DC shunt motor. As the supply voltage is 100 volt and this motor is current is 120 ampere. This is positive end, this is negative end, this one is back EMF. The resistance of shunt field winding is RSH is given to us, that is 25 ohm. This is 25 ohm. So the value of field current IF can be calculated as 100 supply voltage divided by RSH, that is 4 ampere. So as the value of line current is 120 ampere, so this armature current is line current minus field current, and it's sorry, and value of this is 120 minus 4, it is 16 ampere. Now, as the armature current is available, we can easily calculate the value of back EMF EB by using this relation V minus IA RA. IA we have already calculated, and the armature circuit resistance is given. Its value is 0.05. Once we have calculated EB, then we can find out the speed of motor by using this relation. EB is equal to P phi Zn upon 60A. All other parameters are given in the question. Number of poles, it is a 6-pole machine. It has 500 conductors, so value of Z is 500. Also, flux per pole is 0.02 Weber. And for lap winding, number of parallel path means A is equal to P. So first we have to calculate the back EMF. Once this back EMF is calculated from this line diagram, then putting the value of back EMF in this relation, we can find out the value of motor speed. And the question number 4, it is again based on induction machine, but this time it is about single phase induction motor, and it states that why single phase induction motor is not self-starting, what are the methods of starting, explain any one of them. So the separate video on single phase induction motor is already there. You can refer that video, in which it is clearly explained that on the basis of double revolving field theory, that why this single phase induction motor is not self-starting, and the different methods of starting are resistance start motor, capacitor start motor, then permanent capacitor motor, and two-value capacitor. Now moving to the next question paper. This is the questions which are asked in even semester 22-23. Here, describe briefly different types of DC machine. So this is related to the classification of DC machines. And derive torque equation. Again, this question is repeated. Here, we have to derive the expression of armature torque of the DC motor. Again, describe different types of DC machines with necessary circuit diagram. So in the same paper, the same question is repeated, and here it is asked that we have to draw the line diagrams. It means we have to not only draw the line diagrams, but we have to find out the relation between different parameters. And the last question is again, it is related to the operating principle and slip torque characteristics of three-phase induction motor. Moving to the odd semester 23-24. Here there is a slight correction. These are the questions from session 22-23. Odd semester, session 22-23. And these questions are, again, first question is related to the classification. Describe briefly different types of DC machine. The next is derive EMF equation of DC generator. Again, there is a separate video on EMF equation. Describe working principle and slip torque characteristics of three-phase induction motor. And there is a numerical problem which is based on this relation. EG is equal to P phi Zn upon 60A. This numerical is also solved in the video of EMF equation. So while discussing these papers, we can clearly conclude that some questions are very frequently asked in examinations, and we can enlist those topics. As far as DC machine is concerned, DC machines, the important is first is the EMF equation of DC generator, then the expression of torque, then we can say classification of DC machines. It may be DC motor or DC generator. And at last, we can also say this topic back EMF, which is not asked in last 2 year examination, but this back EMF is also very important topic. What is back EMF in case of motors and what is its significance? Moving to the three-phase induction, the operating principle and slip torque characteristics. These are the very frequently asked questions. If question occurs from this topic, question comes from this topic that is three-phase induction motor, then either operating principle of three-phase induction motor is asked or its slip torque characteristics. Similarly, for synchronous machine, its operating principle and various methods of starting are important. And for single phase induction motor, again, why these motors are not self-starting and its various starting methods. So these are some frequently asked questions from examination point of view. So I hope while preparing for examination, you will focus on these topics and definitely going to get good marks. Thank you for watching this video. Thanks a lot.